Dobro jutro. Welcome. So I'm John Pretty. I'm from the UK. I now live in Poland, so I'm making my way sort of east. I work for a company called Dependencies. We do training and work in the Scala community, including a project I've been working on recently called Fury. And in a change from the talk I proposed, I'd like to speak about Fury today instead of Amok, which is a different project I'm working on about documentation. I think because we're we're a small group here today, I'm going to do some live coding with Fury, and I'm going to show you a few features, a few things you can do with it. And while I'm going, please ask me questions. And if you want to, it's a little bit dark out there. I've got bright light shining at me. If you want to ask a question, wave your hand. If I don't see you, shout. And I would love people to just shout out with questions and ask me anything as I'm going. Now I work with a company called Virtus Lab. They provide me with support, and they give me engineering work on this open source project. So this is a bit of a shout out to Virtus Lab. If you're looking for a company to help you with Scala development work, or if you're perhaps looking to move to Poland and work in Scala full time, then speak to Virtus. What I'm about to show you is the product of my collaboration with them. So Fury, if you don't know or haven't heard anything about it, is a build tool that is currently in development. I've been working on it for over a year now, and it's been progressing steadily towards being what I hope will be a usable alternative to SBT, Maven, Gradle, and so on. Now Fury takes a slightly different approach to those build tools. I'm not going to talk about those differences up front. I'm just going to dive straight in and show you how you can use Fury. If I do start using something or showing something that doesn't make sense, this is the opportunity to shout at me and ask what's going on. So I'm going to start by running the Fury command from the command line. This is just normal ZSH terminal. And I'm going to clone a layer. Now you see I'm pressing tab and getting tab completion. And I press tab to on the -L parameter to clone what is called a layer. And I'll show you what this is. So I'm going to clone the Scala/new layer into a directory which I don't get tab completion on. I'm just going to call that new project. If I do that, something happened. It actually created a new directory there called new project, which appears to be empty. Now this has cloned what I call a layer. You can think of a layer as a collection of projects. There is actually one hidden file in there, which gives Fury the information it needs to associate this directory with a build. And if I list the projects, you can see that we are bootstrapped with an empty project that has the Scala compiler. It has an unknown license. We haven't specified that. The description is not particularly interesting. And it has one module, as you can see there. If I list the modules, we can see that module is called core. So there's a structure or a model for the build becoming clear here. We have a layer contains several projects. A project potentially contains several modules. And a module is what I think of as an atom of compilation. It's some source code that we're going to convert into some bytecode. That is typically what a module is. It converts source code into bytecode. So let's have a look here. There's no source directory, though we can see that this module is specified to use a source directory here. But we've just cloned this empty repository, empty layer. So let's create that directory and create an empty, well, a boring source file. So I'm going to write this simple Hello World application. Now tell me if I make a mistake here. You've probably all seen Hello World before. Does that look okay? Yeah? So I've added that, and well, let's just try and run that. So I run the Fury command, and it goes and compiles that and says build completed. Well, that was quite easy, but there's no proof it did anything at all. It didn't print hello world. That's because that module is just a library. When you write a library, you don't run anything. We want to actually run that main method. So let's update the module. And let me just write these out in full. I'm going to specify the type of this module to be an application. Applications not only get compiled, they also get run. And I should probably specify the main method, which is hello world.main. And then if I run that again, it'll actually recompile. It doesn't need to, but that's a bug. In future, that will be cached. That has compiled. It also ran. That's why we see hello world output. So I think that experience is probably easier than the SBT experience for getting started with a very simple project. Notwithstanding the fact this is all a new model for how you write a build, does that seem easier to you? Yes. Yeah, okay, good. It's working so far. But I haven't added any dependencies. And this is where it maybe gets more interesting, because Fury doesn't rely on binary dependencies. It uses, as much as possible, source dependencies. Now, we can depend on binaries from Maven, but you get the experience of writing a build is not so good with binaries. We want to depend on sources because it gives us more flexibility for example, resolving diamond dependencies. And I'll show you an example of that later. But for now, I would like to add a simple dependency on another project of mine called Gastronomy. Gastronomy is a really simple project that provides digests, hashes for various types of object. So in order to depend on that, Fury needs to know where the build is for Gastronomy. It needs to know where the source comes from. What I'm going to do is modify my current layer. Now, layer is the collection of projects, to import another layer into scope. What that will do is it will make available to me all of the projects in that other layer. So I'm going to say Fury layer import. I'm going to give it a name, Gastronomy. And the layer I will import, if I press tab, I get a list of suggestions. There aren't many at the moment because I'm still sort of bootstrapping the Fury ecosystem. But you can see there's several things suggested there. And propensive/gastronomy is the name of the layer which I want to import. And I'll just add another parameter here, which I won't explain for now, but that's going to... Yeah.
Where are the repositories for these being fetched?
That's a good question. Where do the repositories come from? Where do the layers come from? And I guess you'd like to know, how does it know what is available? I will answer that very shortly. I'm just going to demonstrate how you can... I'll demonstrate adding the dependency, just so people have a clear idea of what it means to import into the layer, and then I will explain in detail where that comes from. But it's a good question. So I've added that layer, and I can now run the Fury layer projects command, which will list everything that's available to me. So not only is my new project, this is the one in my current layer, available, but I've also got Gastronomy, and as a consequence, we also have Mercator and Magnolia, two other things which it turns out Gastronomy depends on, and we have the Scala project, which provides the compiler. And I want to add a dependency, a link to Gastronomy core. That was instantaneous. I got tab completion on on various things here. These are all the modules that I can depend on from my current module. And I'm just going to edit that source so I actually use gastronomy here. And let's just hash that string. So instead of writing hello world, I'm going to write some sort of hash of hello world. So let's write digest, and we'll take the SHA-256 digest, and we will view that encoded as hex. So let's just run that again. Now the graph has changed. So because I added that dependency on gastronomy, that's pulled in Magnolia, it's pulled in Mercator, and now it's building these. Step by step, it's not a very interesting graph because they build in sequence. Oh, well, it's not necessarily true because it's building them in parallel, but that has now run. You can see instead of printing hello world, it prints this long hash. So again, that was quite easy, but the question was asked, where does Fury know where to pull that from? So this is one area where there needs to be some sort of centralized list, if you like, of things you can depend on, of layers that contain projects, in the same way that we have Maven Central. Now, I really wanted to remove any sort of centralization from Fury. I don't like the idea of having a single point of failure, but we do still need some sort of way of distributing amongst everybody this list of what's available. So what the approach I came up with was to specify a service, which is effectively just a domain name, that will provide a reference to a catalog of layers. And the layers are distributed through something called IPFS. How many people here have heard of IPFS? So fewer than half. IPFS is a global peer-to-peer network that basically has a very simple API and that works very nicely. The API has two important methods. If you give it a file, IPFS will give you a hash relating to the content of that file. And it will also make that file available over its peer-to-peer network. If you give it a hash, it will give you the file back. So although there's theoretically not a one-to-one mapping, the hashes are large enough that the possibility of a conflict is basically zero. And we do have a one-to-one mapping between a hash and some data. And that is actually a really exciting project which I wanted to take advantage of. And what Fury will do is it will make a layer available through IPFS, which means that we can just include a hash of that layer as a reference to the actual definition of the layer, and IPFS can give us that back over its peer-to-peer network. I use something as simple as DNS to update the service that provides a reference to IPFS that has the catalog. So when I write, for example, Fury layer clone, and I press tab here, when I hit tab, that does a DNS lookup on a domain name that is configured by the user. It's bootstrapped with a server I've set up that has this, but that DNS lookup will give Fury back an IPFS hash. It will then go off to IPFS and say, give me the content relating to this hash, which is a catalog which contains these 8 layers. Then when I select one of these layers, the catalog gives Fury the IPFS reference, the hash, in order to look up the full build relating to this layer. So this would be easier to explain with a diagram. I hope you've followed my verbal description sufficiently. What it means is that although there is a single server at the moment that is providing that catalog, that catalog is provided over a peer-to-peer network which is fully distributed. It's using DNS, which should be resilient to a server going down, It actually has multiple, by default, has multiple servers serving that DNS. And if you wanted to use a different service for getting that catalog, you could set that up. That's all possible within the scope of Fury. So again, as much as possible, I've tried to avoid any single point of failure. It's a question, I think. Alex.
So 2 things. First of all, I'm assuming you didn't just recompile Scala and Magnolia, et cetera, et cetera. So I'm assuming that there's some...
Wrong. I recompiled Magnolia, but I didn't recompile Scala.
Okay, okay.
So Scala, just to quickly answer that, Scala, I pulled in the binaries, and that's actually why the Scala compiler appears grey here. It did no compilation, it just used the binaries it had. Mercator was compiled from nothing. Magnolia was compiled from nothing but Mercator. Gastronomy was compiled from Magnolia, and then it did everything together.
So all these things were just compiled from source?
Exactly, yes. Does that invalidate all of your other questions?
I was going to ask, like, what if you have a compile cache, but basically...
So the answer to that is, the question is very good. Like, do I have a compiler cache? Now, if I type Fury again, I'm not exactly sure what will happen because right now it's actually recompiling everything. That's the answer. I'm relying on Bloop to do the compilation for me. Now, Bloop, how many people know of Bloop? So actually, at least half, I'd say. Bloop is a fast compile server for Scala. I give it source code, it gives me bytecode back. It will do incremental compilation if it can, and it should cache builds if it's possible. Now, from Fury's point of view, it just sends the work off to Bloop, and Bloop gives it a response back. I treat it as a bit of a black box. Now, for some reason, Bloop is not caching these builds. It, in theory, could, because we know we haven't changed Mercator, or Magnolia, or Gastronomy. So it shouldn't do the recompilation here, and sometimes it does, and sometimes it doesn't, and I at the moment, don't know why, but I could do some additional caching on the Fury side to say that I know these things haven't changed, therefore I'm not going to send the recompilation work over to Bloop. Sometimes it does cache them, so it would potentially not need to recompile these all from scratch. But as you can see, it is actually quite fast. This is compiling 4 different projects, and it takes. It gets faster each time as the JVM that is running the compiler gets warmer and warmer. So you probably can't see these timestamps because of the screen, but 9.3 seconds from requesting the compile through to getting a response, compiling 4 things from source. Once we've got caching working properly, that will be instantaneous, more or less, like under 0.2 seconds, I would imagine. Did I answer everything, Alex? Cool. Yeah.
How is it that the completion and execution for Fury is so fast? Is it native or is it...
No. So the question, if you didn't hear, is how come it's so fast? The reason is Bloop. So although I'm sort of complaining that Bloop is not caching these when it could, Bloop is also what makes these so fast. So if you're comparing it to SBT, that's not really comparing like and like. So SBT has to compile the build, and then when it's compiled the build, it will run the build, and then that will involve invoking the compiler and getting the result. We don't have a build that is defined by source code. Our build is defined by data, which means there's nothing to compile. It means there's no potential Turing completeness in the build. It is simply a data structure that exists it's actually a nested set of case classes that defines the entire graph for the build, and we run it. That part is instantaneous. So if it seems faster than SBT, that's why. If the compilation seems very fast to you, that's because when you run the Scala compiler in a JVM and you run it a few times, the performance speed up between a cold JVM and a hot JVM that's applied hotspot to all of the common paths is about 2 to 3 times, sometimes maybe even more than that. And this is running in now a hot JVM. Also, those projects, Magnolia, Gastronomy, and Mercator, they're all pretty small. They're not large amounts of code. I will show you an example later using some larger projects. There was a question. Yeah?
Yes, maybe I still don't get it, but if you could explain actually, because at the end you wanted to get the gastronomy core into your project, so a dependency.
Sorry, I wanted to...
gastronomy core, yeah?
Yes.
You add it as a dependency and then you could actually use it?
Yes.
But before you had to add some layer, as you call it.
Yes.
Why is this...
Why is it a two-step process?
Yes, and
Yeah.
How can you actually get a dependency right away without knowing the layer it belongs to? So
Okay. So it's a two-step process because we have to... Fury needs to know where it is getting a build from. That is the step of adding the layer. Now, layers are defined a bit like a tree structure. So a layer imports other layers, and those layers can import other layers, and it sort of forms a tree, a tree of imports, if you like. This allows Fury to resolve the definition of a project, and this is actually a key part to the way distribution of projects will work. Now, you've maybe experienced diamond dependencies at some point with, if you're using Maven or SBT to resolve dependencies. Now, with any particular dependency published on Maven, it will have a version number. And if Maven or SBT encounter two different versions of that same binary via different paths, what it will do is it will silently upgrade one of them to the more recent version. It will take a guess as to which one it should use. Now, that is problematic for a few reasons. The biggest is that there's no guaranteed API compatibility or no guaranteed binary compatibility between the two different versions. So if one binary has been compiled against one version of a dependency and another binary is being compiled against a different version of that same dependency, and there is some mismatch, when that gets collapsed into a class path, linearized into a class path, only one of those two versions will survive. The other one will be shadowed. And it means that one of those dependencies could be trying to access an API, a method, or a class that simply doesn't exist on the class path. Now, this will manifest itself as a class not found or a no such method error, which is a runtime error. That's something we really don't want. Runtime errors are the worst. We want compile time errors. What Fury will do is it will tell you if you're depending on two different things, or depending on the same project but two different versions of that project. And it will refuse to build in that case. It will say you must fix this problem. And it gives you ways for doing that, which I'll show you later. But one of the more fundamental problems of using or writing a build is resolving dependencies. Now, I introduced the concept of layers as a means of trying to minimize the amount of work you have to do in resolving conflicts. Layers are, like I say, they form a sort of hierarchy. And if you import more than one layer, in the same way that if you have more than one dependency on SBT, if you import more than one layer, then there's a risk that you'll have two projects with the same name but different definitions. Say one of them imports shapeless 2.3 and one of them imports shapeless 2.2. That's something you want to avoid, or rather you need to fix. Now, one of the rules of using layers is if you pull in two layers, which brings in several projects into your layer, and that introduces a conflict, before you can publish that layer for somebody else to use, you must resolve the conflict, which means that any layer you publish will already be fully resolved with no diamond dependencies. And therefore, if you do import more than one layer, well, if you import only one layer, it means you can't possibly have a conflict, because that layer must, if it's imported, it must be, if it's published, if it's imported, it must have no conflicts. If you import more than one, then there's a risk of a conflict, which you must resolve before you republish your layer. So that's a whole lot of background about layers, which I'm explaining to try to give an answer to the question, why do we have two steps? Layers and the concept of layers deal with dependency resolution, but it doesn't actually specify the dependency. A layer may actually contain hundreds of projects. So the likely structure of layers would be that any project like Shapeless or Cats or Monix, say, would be published as a layer. But then you might get another layer, such as a hypothetical type-level layer, which imports Cats, imports Shapeless, imports Monix, all into the same layer. Maybe that layer doesn't even define its own projects. It simply aggregates some existing layers and then republishes them. But it republishes them fully resolved. So when you import that layer, you know that you're using a consistent and coherent set of dependencies. It means they're guaranteed to work together. It means that they will compile without any sort of linking error happening at runtime. So I anticipate that when you import a layer, you won't typically import just the gastronomy layer. You would import something like the type level layer, which would give you access to all the type level projects, and maybe one or two extra layers. Or you might import, for example, the Scala ecosystem layer, which, let's say, aggregates type level and aggregates those other projects. So there's sort of a stratified distribution mechanism. You can distribute fine-grained layers, or you can distribute large aggregated layers. And this example I started with, the Scala/new layer, which I cloned, that's like a template for a basic Scala project. I could have defined that template to automatically import the Scala ecosystem layer, which would have meant that I wouldn't need that additional step of importing the ecosystem layer. I could simply add the dependency, and I would be able to add the dependency, and when I press tab here, I might get hundreds of things I could depend on just available straight away. That's sort of the vision for how things may look when we've got more and more projects published with Fury, more and more layers. That seemed like a very long answer for what was a simple question. Did it actually answer the question sufficiently? Do you have another way of phrasing the question that I might be able to answer, or would it be easier if I just carry on?
Yeah, so my question was more from the somehow user point of view.
Yeah.
So let's say I want to, use, for example, Cats library.
Yeah.
But I don't care which layer is it in. I don't care. I mean.
Do you care which version you use?
Yeah, I care. Yeah. So
do you care what it's compatible with?
Yeah. So this is the thing, that because you just showed us simple dependencies. I guess you can specify, of course, what versions and so on. But can it be somehow resolved at the dependency level? So, because I anyway need to care about the layer right now. I need to add the layer first.
Yes.
Then it's like I understand it as a local index. My local index that I can actually refer to get the dependencies to my projects.
Yeah.
Otherwise, I cannot.
So there are a few questions. Do you care about having the latest version, or do you want the version that is compatible with everything else?
Yeah, let's say I have already some dependencies in my project, so I want to have something that is actually working with mine.
Yes.
So will you have also like I don't know, a version specifiers in the dependency that you can say? Like expressions for the versions, or
not as such, but you would different layers would have different versions. I think maybe a different attempt to answer your first, or maybe different. Maybe if I just repeat a detail from my previous answer, that might help. When I at the very beginning, when I said Fury layer clone, and I said Scala/new, that created a new directory with a pre-existing project. If that pre-existing project not only had the Scala compiler set up, but additionally had access to the ecosystem layer, which you can think of as equivalent to a reference to Maven Central, except it's not Maven Central, it's my own Fury ecosystem. In that case, if I had set it up that way, and maybe the next time I do this, I will do that, I would already have those dependencies available. It would be a single step. What that would give me is access to the curated version of cats, the version that that layer has published, which has already been resolved of any conflicts. That might not be the most recent version of cats. It might be that the most recent version of cats is not compatible with a version of Doobie, say. I can't remember if Doobie uses cats. It doesn't, but it's something that depends on cats. There might be other reasons for using different layers. You might want a more fine-grained approach, in which case you wouldn't import that full ecosystem layer. You would import maybe several different layers, and you would do the resolution yourself. Now, you maybe have noticed when a new version of Scala is released, the Scala 2.13 was released this summer, it took a very long time for all of the libraries that were previously published with Scala 2.12 to publish with Scala 2.13. That's because we currently use a single centralized repository, Maven repository, for storing and sharing those binaries. And you can only publish a binary if all of your dependencies are published, which means we've sort of got a waterfall approach to publishing. We can't publish unless all of the things we depend on, all of the authors who own those libraries, have gone to the effort of publishing. And they can't publish unless everybody they depend on has published. And this actually makes it quite slow. It means that you can't start using Scala 2.13 on the day it's released. You have to wait for other people to do work. And I know that certain people who maintain libraries, such as Bill Venners, writes Scala test. He has to be very aware of when Scala, a new version of Scala comes out, because he knows that if he doesn't publish Scala test, he'll be personally, this is how he feels, he'll be personally holding up the entire Scala ecosystem, which I think is absolutely wrong. If you're devoting your time to open source, you shouldn't have this burden on your back, which suggests you're holding up the ecosystem. Bill, I know personally, feels this, and he actually pays somebody with money out of his own pocket to do the publishing for him because he's worried that he might be kind of held responsible. With Fury, you can start using the build immediately. If Bill hasn't published, it doesn't matter. You publish it. You upgrade Scala yourself. You've got access to the build. You can make those modifications. Anything which depends on Scala test, you can pull in the latest version as a layer. You can do the resolution yourself. You can compile everything. Fury has access to all of the builds and all of the sources, so it doesn't need to go through this slow waterfall publishing process. From our point of view, and from the point of view of the average user, I think you would want to start with an empty skeleton project that pulls in a sort of generic community build or ecosystem that already has most of the projects you would want available. And that step I showed you, where we add a layer and then add a dependency, would be just a single step where we just add the dependency. I'll stop talking about that now. Was there another question? Yeah?
More than a question. Can we, sorry, could you summarize bluntly layers with, say, the Spring Boot parent POM? Just guessing. I
I don't know enough about Spring Boot, thankfully.
Yeah. It's my curse.
I didn't go through that period of my career. I did very briefly in about 2004. I don't know, does it sound like that to anybody else who knows Spring Boot?
Or the parent POM for an ecosystem is basically you inherit your project, your POM inherits from some other parent POM which contains a bill of materials.
Yeah, so the layer, the layer defines the projects define the modules, and it's the full specification from how you clone the sources from Git to how you compile them in what order to make a binary. So that's what the layer defines. That's what, when I talk about a layer, that's what's being distributed. That's what's being put onto IPFS. That's what we are copying and cloning. There are no binaries in use, apart from I mentioned I did depend on the Scala compiler as a binary, but whether that's similar to Spring Boot, I honestly don't know. All right, I will.
Sorry. Maybe the word layer is causing some confusion. Is it something like a curated distribution of packages, versions that work well with each other?
Yes. It might be curated, or it might just be one project.
Okay.
So it can be anything from very fine-grained to a huge collection. But it does have this constraint that if you publish a layer, you must publish it fully resolved without conflicts. It must be self-consistent. It might be inconsistent with other layers you import, but if you import more than one layer into your layer, and you want to republish your layer as a curation, as a collection of projects, you must do you must resolve the conflicts.
Okay. Thanks.
Okay. So I'm enjoying all these questions, but it is using up a lot of time. So just to remind you what we had there, we defined this. We printed out the hash. Now this is actually very useful background to something that Fury does very well. It has access to all of the builds for the entire tree of projects. It has access to all of the source code. So let's say we're developing our project, but we want gastronomy to work slightly differently. Now, I happen to be the author of gastronomy, but say it's not my project, it's somebody else's project. And I want to change it, because I'm an open source developer, I want to contribute back, and I want to, first of all, experiment what it would be like to use some variation of gastronomy. Now, I'm just going to leave this compiling. I'm using the -W flag to set this into watch mode, and it will watch for changes. It will recompile each time, and you see it's waiting for changes there. Actually, I want to do something else first. I want to show you that if I list the projects for my layer, there's only the current project. It doesn't include the imports. But if I select a different layer, I can actually navigate through my hierarchy of layers to the gastronomy layer. Now, what that will do is that will basically change my context. So I'm now effectively editing that dependency layer. I have access to all of the projects here. I can also list all of the repositories that layer depends on. Gastronomy, Magnolia, Mercador, exactly the same as the list of projects, but this is where the source code is coming from. And these Git repositories, so it's GitHub, Propensive/gastronomy, and so on, this is the commit hash that's currently being used for each of those. They get cloned into a hidden directory somewhere in a cache. And the source code in there gets compiled. But let's say I want to edit that. Let's say I want to edit that source. I can actually fork those repositories out of that shared space. And let's fork gastronomy into another directory. So that actually just moved the directory. There is the contents of that gastronomy repository. Now, like I said before, I'm just going to leave this compiling. that will notice changes when they get made. I'm actually compiling just gastronomy at the moment because I'm in the gastronomy layer. When this finishes, I want to go back to my project layer and then recompile everything. So it's recompiling gastronomy from actually different sources. Fury layer select. So I'm back in the main layer, and now I'm going to say once again I'm going to leave this compiling. And if I go to a different shell, and there is my gastronomy repository. It's actually in detached head mode because this is the exact commit hash that was being used before. This other shell has finished compilation. Now, if I were to edit the source code of gastronomy, so I'm basically editing a dependency, and let's say that encoded method which I was using, let's say I don't like the name encoded. I want to call it print as. So everywhere I see encoded, I'm going to change that to print as. So it only appears in 3 places. If I save that and then go back here, it's noticed the change that I made to the dependency. For some reason, it hasn't recompiled as I intended it to. Let me. No, it wasn't that. I think I think there's a. I think what actually happened is there was another build that ran in the background. Yeah, this is work in progress, of course. This is why it hasn't been formally released with version 1.0 yet. So it's recompiling, and the other bug which you can't see here is that compilation failed, and it's not reporting the error, which is why you don't get the output anymore. So that is a bug that you can't see that. You have to trust me that compile failed. For some reason, we lost the output. If I go back to the new project and I edit this encoded method doesn't exist anymore, but if I change it to print as, save that, it will hopefully notice the change, recompile, and this time it should run because that now links. So apart from the issues with not showing the compiler errors, not reporting that it failed, it was very easy to modify a dependency directly, just to change the sources. Now I could go back to gastronomy over here. I could add that change, renamed encoded to print as. I could push that to get, I could create a pull request, and I've very easily contributed back to an open source project. That was really easy.
Sorry, can I ask a question?
Yes, I can't see where you are, but
here.
Hello.
Hi. So you used a new version of gastronomy, which you forked in your layer, and then you used that layer in your new project to do a change on the fork and then compiled and then released, okay?
Almost. I would say that I forked it, and all of the references to where Fury gets the source code from changed to that forked version. So that sort of happened transparently.
Yeah. Okay.
Yeah.
That's why exactly what I was going at, because when you're doing the compilation here, it's not very obvious that that a fork has been made, and it's not very obvious that a fork has been made, that you changed the gastronomy core to do your change somehow. I mean, it's your yeah.
So as a user, you wouldn't necessarily be able to tell the difference between the modified version.
Yes.
Maybe that's true. Yeah.
That was it.
Yeah.
One point.
I mean, it would have been obvious if we'd seen that it produced the error. Unfortunately, I wanted to show you the error, but that wasn't working. Yeah, maybe the user interface can be improved around that. What would actually make it? What would actually be a good indication is if we saw gastronomy recompile when everything else was used from cache. I think because everything is being recompiled every time, it's not obvious whether the compiler is doing any work or not. Yeah, maybe that could be improved. Two questions in the middle.
Sorry, man. So first, just quickly, what about, I mean, when you publish binaries for different Java versions, for different like drivers, so for instance, I noticed this, the gastronomy is using XML bind, which is not available on Java 11. It was completely removed. So it will not, yeah, it's going to explode. The same thing as builds.
No, I mean, is it using it?
Yeah, XML bind data type converter is gone.
No, I mean, is gastronomy definitely using?
Huh?
Is gastronomy definitely using that?
Well, I just saw it in there. Also,
oh, right, okay.
Also builds a super save, doesn't work with Java 11. So the thing is, like, when you say that this is conflict-free, it's only in some branch of an operating system that you made it compile on and against a Java version. So should it be tagged with this? This works on this range of Javas, on this range of OSs, because a lot of libraries depend also even binary artifacts that you cannot simply produce on your machine. It's not possible for you to distribute it and repackage it in the same way that the original author did. It's a fairly complex setup for some complex libraries. So while I understand that this is definitely better for diamonds, I don't see it how you could publish complex, perhaps proprietary libraries in an internal.
Well, you can depend on binaries. We can say we can add a binary and specify the file or the Maven coordinates with a command like this. With the dependency on Java, in that particular case, I'm going to add support for optionally specifying an exact version of OpenJDK. Now, this is a dependency manager for generally, well, Scala and Java. There's nothing here that doesn't add utility to Java as well. But I don't want it to become something which is OS dependent. I want it to be, I want it to sort of follow the original Java philosophy of write once, run anywhere. So define the build once, run the build anywhere, if you like. But as you say, there are various dependencies on the Java runtime. In those cases where that matters, I would allow people to specify not just not just binary dependencies, not just jar dependencies, not just additional source dependencies, but also specify the JDK version if that matters to you. Alex, yeah? Yeah, sorry, I really don't want to sort of bring your presentation to more of a halt, but there was a question previously here about, that this really is sort of similar to what we see in the Maven world with the dependency management / what we would call a BOM or bill of materials POM file. I think layers are surprisingly similar to that, and in fact, I would say in general, I don't know if this is something that you'd like to hear or not like to hear, but I think actually that Fury has a lot more in common with Maven than SBT. In particular, Maven got a lot of criticisms in the beginning where they said, oh, it's not Turing complete, it's not Turing complete, but I think the power of Maven was that it was not Turing complete, and that's why you could introspect on it a lot more easily and understand all of the different kinds of variations that your build produces. So I think if you say it's more similar to Maven, I would like, I need that to be qualified with the aspects of Maven which which it has in common, and using a data format like pure data rather than code for the build was a very clear decision I made early on. I didn't want to have to do all sorts of calculations in order just to understand the build. I want that data structure to be able to be inspected, analyzed quickly. I want the user to be able to run a command and instantaneously get a specification for the build, to see, for example, the structure of the build as quickly as that. That's something that you can't do with SBT. It needs to compile the build first. Fury is able to do this because it does have access to all of those builds all the time as source. Now,
Sorry, so my question was...
You still got a question after all of this?
I'll let you go. That's fine.
So I'm just because I've only got 3 minutes left, and I don't want to run into the next talk. Let me just show you an example of adding some more dependencies. Let's add some more layers. We saw Zio last night, so let's add a Zio layer. I need to give it a name, and I need to specify the default schema. Let's, what else have we got? Type level cats, let's include that. Let's put Zio and cats in the same project to see how that works. This shouldn't be called Zio. Let's add a dependency on, so you see I've added these layers, I'm getting more and more projects available. Cats core, and let's add a link to Zio core. And if I try and run this, what will happen is from that cats definition, it knows that it needs to clone the cats repository. Now this is happening over my network connection. It's got quite a lot to download for cats because cats is quite a big repository. So this will take a little while. When it's finished cloning cats, it will start to build it, along with building everything else that it depends on. I think Zio is already cloned and cached in my Fury cache. So when it finishes cats, it should actually start building quite quickly. But when it does, it will display a bigger graph than we've seen before, because there's all the dependencies of cats, all the dependencies of Zio. It's checking out these. So not only does it check out the repository, it checks out directories from within that, which are the source files it's going to compile. So now it's compiling everything. Now I want you to watch this graph carefully. It's compiling 4 things in parallel at the moment. This is 4 different runs of the compiler, all happening at the same time. Now, you will see that it's building cat's kernel, and cat's core down here is also highlighted at the same time. Now, cat's core depends on cat's kernel. And you're maybe wondering how it can start building cat's core before it's finished building cat's kernel. It's a reasonable question to ask, if there's a dependency between them. This is using a feature of Bloop called pipelining. Now, it turns out that in order to compile one project, you don't actually need the bytecode from its dependencies. You only need the method signatures and the types. And these become available much earlier in the compile process. So it's actually possible to start building cat's core, and in fact it's possible to start building our new project, which depends on cat's core, before cat's core has finished, or before cat's kernel has finished. This gives us better parallelism. It gives us faster builds, and it means we can actually get much better performance from our builds by parallelizing different parts of the compilation. This has now built cats from source, it built Zio from source, it built Magnolia, Simulacrum, Kind Projector was a binary. All of that was built from source. It took 153 seconds. If I ran that again, it would actually be quite a lot quicker because it wouldn't need to clone everything. And actually, on a hot compiler, we would see that works that works faster. So I'm going to finish there because I have overrun a little bit, and Wiem will need to speak soon. I'll leave you to watch this build, but hopefully this has given you an overview of some of the features of Fury. I didn't show you half of what I wanted to show you, but you asked a lot of questions, so hopefully you got something out of it. So thank you.